My name is Suchit Anand and I work for the Global Open Data for Agriculture and Nutrition. So for those of you who are new to GODAN, I would like to specifically welcome you all to the Global Open Data for Agriculture and Nutrition. And we support global efforts for agriculture and nutritionally to make agriculture and nutritionally relevant data available, accessible, and usable for unrestricted use worldwide. The initiative focuses on building high-level policy and public and private institutional support for open data. And we encourage collaboration and cooperation among existing agriculture and open data activities without duplication and bringing together all stakeholders to solve long-standing global problems. So we are very grateful today to have GODAN Action colleagues to present their project with us, and it is a great pleasure to welcome both Rob Lokers and Valeria Pesce from the GODAN Action project for presenting their ideas on the webinar. From GODAN, I will also want to specifically highlight and welcome you all to the working group on capacity development, and invite you to, if you are new to capacity development activities in GODAN, please consider joining our working group. There is a screen which you will see now, which will show you how to join. It's a very simple form, and you can fill the form, and then you can join in our mailing list, and you can join a global community and share your ideas on capacity development and be part of the capacity development activities. So today, this particular webinar is a very interesting webinar and very important as well, because it is focusing on the use of standards and steps to achieving impact with open data. And GODAN Action is an important project which has been in place now at least 1 year. A lot of interesting activities happening, and you will hear from both Rob and Valeria on their perspectives on this. So I want to introduce our two speakers to you. First, I will introduce Rob Lokers from the Wageningen University. Rob is a project manager of ICT projects and research infrastructure at Altera Wageningen University, and he has long years experience in information systems development in scientific and commercial environments. His expertise is in ICT and data science in various domains, from agriculture, food security to environment. He also has expertise in research infrastructure, knowledge technology, and agro-environmental modeling. Currently, Rob coordinates, among many other things, GODAN Action project, and his focus is on achieving impact by engaging with open data in agriculture and nutrition. Our second speaker is Valeria Pesce from GFAR. Valeria is currently the Information Systems Manager at the Secretariat of the GFAR, the Global Forum on Agriculture, Research and Innovation, and collaborates with the Secretariat of GODAN as well. She has represented FAO and GFAR in the past and current European Commission funded projects on data infrastructures, and manages this CR Ring Datasets Hub and Agri Profiles platform in coordination with other global and regional actors. She is also coordinating the work around global map of data standards for food and agriculture for GODAN Action. So today's webinar, we are very happy to have these two great speakers with us. So we will be recording this webinar, and I will invite all participants, if you have any questions, please do put those questions in the chat window, and we will answer these questions at the end of the webinar. So we will first have I will hand over to Rob, who will present the introduction and all aspects from his end, and then we will move to Valeria. So thank you all for joining, and I'm now giving the floor to Rob.
Good afternoon, everybody. Thanks for joining this meeting today. Well, I'll be talking a little bit about GODAN Action, especially about the work that GODAN Action does on impact evaluation and impact assessment, trying to, let's say, get an impression of how we can improve impact in development countries and development initiatives with open data. So there's a few things I want to talk about. First of all, a short introduction about GODAN Action, its approach and its activities, to give a little bit of the perspective of the whole project. Then something about our work on impact evaluation of open data initiatives. And well, one of the subjects of this specific presentation is the role of context and the environment of open data. So I will go into that, and I will give some examples from specific projects where we have applied the work that we have done till so far on impact evaluation. So first of all, GODAN Action. What we actually do as part of the GODAN initiative is that we try to support people in engaging with open data. So that goes further than just advocacy. We also really bring support to users in different aspects. Well, impact evaluation is one of them, but we also do a lot of work on standards and interoperability, where Valeria will go into in the second half of this presentation. And we work on capacity development to bring our knowledge to people in the field. Then open data. Well, we see open data as a solution to problems. And to really get practical with this, we have chosen an approach where we work along thematic topics. So we're not looking at open data in general, but we focus on specific domains and topics that our stakeholders think are of high relevance. First of all, we try in that way to work on domains that are, let's say, essential to open data. And second of all, we want to put research into practice in those fields and achieve impact. And we have chosen for 3 topics in that respect. The first one is climate and weather data. That's the topic that we're concentrating on in this year, in 2017. And next year we'll be also supporting the topics land data and nutrition data. And you will see that a lot of the examples that I give are currently based on weather data initiatives. And yeah, they give a good example of how we bring our work in practice. So yeah, this is another perspective on our approach, more looking from the real data perspective. And open data, of course, is kind of the raw material that we're working with. And open data in itself is usually not of very much interest to end users. You have to do something with it, and there's all kinds of stakeholders involved, like data providers, but also intermediaries that take the data from open data providers and that make, let's say, added value information and knowledge. Finally, we'll bring it to the user, and yeah, you see this pyramid where you kind of work up open data to information and knowledge, and eventually to, well, we call that wisdom. It's kind of a strange term, but it's actually, let's say, people using the information and the knowledge in their actual problem solving. So one of the things we do in GODAN Action is developing impact evaluation methods, and well, we do that from scratch. We base our knowledge on existing knowledge base, and we try to also apply it to initiatives that engage with open data, and specifically in these thematic topics that I mentioned, and also taking into account local boundary conditions. So looking at, let's say, real projects, real work in progress in the field, we can apply these to specific conditions and see how our evaluation methods work. So it's, yeah, also applying and testing those methods. It's not only the theoretical work, the research, but also applying it. Then, well, first of all, a little bit about existing methods. We did some research on that, and well, we found out there's actually not that much available on evaluating impact for open data initiatives. There's a few relevant ones, we think. One of the Sunlight Foundation, which focuses on development initiatives, and that one focuses especially on the social impact, so it's quite targeted to that. And then there are 2 more or less linked frameworks and methods from, let's say, a group of people working on open data, and they have set up a common assessment framework for evaluating impact. And that's really nice. I mean, you see great examples of evaluations of projects, but there are a few issues with that. First of all, all those methods are more or less aimed at evaluating impact after, let's say, the finalization of a project. So it's the post-project evaluation. And they have different perspective. For instance, that the Sunlight Foundation's method is focusing on the social aspects, and you also see that they kind of miss out on some of the aspects we think are also really important. For instance, let's say the business and the innovation aspects. So we thought that it might be useful to also take a look at the methods that could kind of tell you something about impact in the process itself. So not at the end of the project, but during the project, and also to be able to tell something about, let's say, relatively small-scale projects. So if you look at those methods, and you see that's in general very difficult to attribute the role of open data in let's say, the impact of interventions. Usually open data is just part of something that's done in practice, it's part of an intervention, and it's really hard to separate, let's say, the share of open data into the total impact of something you do. Like I said, post-project evaluations are valuable, but they are quite demanding regarding efforts usually, something maybe psychological, but also financial budgets and intrinsic motivation are generally quite lower at the end of the project. And there's some things missing. It does not offer ways to establish preferential conditions for interventions, and it also doesn't provide means to monitor and to proactively steer within an initiative when you're, let's say, working on a project. There are some disadvantages to existing methods, so we thought, let's take a look at something which can be applied early in the phase of a project, and which can also be used to let's say, evaluate smaller projects and to steer a little bit within a project. And that's where I think the context comes in. You can see it a little bit in existing methods, but there are quite some, let's say, conditions that are crucial if you want to really successfully deploy a project by open data as a role. First of all, there's the policy environment. Very important is that there is, let's say, the political will and commitment in supporting, let's say, open data. And, well, connected to that, let's say, a legal framework, let's say, clear rules and regulation about how to deal with open data, how to work with open data, are very relevant. Skilled stakeholders, of course. I mean, you can have open data, but if you don't have the people who can work with it, who have the technical skills or the communication skills needed, except, for instance, to, let's say, convert data into something like a good visualization, which is, let's say, comprehensible for end users. Or if you don't have the economic skills, let's say the knowledge of business models to exploit open data and to, let's say, in the end, make it profitable, then it also gets really hard. Then, of course, there's a technical environment, access to ICT for all kinds of stakeholders, data providers, intermediaries, and end users is very relevant. And last but not least, let's say the economic environment. The general business climate is specifically important if you look at, let's say, the innovation and business aspects of, let's say, the impact of open data, and the opportunities for co-development are also very important. So how easy is it to establish public-private partnerships, for instance, and innovation capacity in general. So how about weather data? Like I said, this is the topic that we're focusing on this year. And, well, you probably all know that weather is quite important for farmers, for smallholders. And there's a lot of things going on in weather and how it develops over time. Weather patterns are changing, seasons are changing, gets less predictable. So risks are getting higher, and there's a really high demand in, let's say, kind of covering those risks, and let's say weather data and information and knowledge derived from weather data can play a very important role over there. So, and again, this is not something of just, let's say, publishing weather data. It's about, let's say, producing added value and co-creation between a lot of stakeholders in the field, like farmer organizations, business, and government. What we actually do also in this year is focus quite a lot on, let's say, the middle of the added value chain of open data, the service intermediaries. There's a lot of work done on, let's say, working with governments and looking at things like accountability, transparency and stuff like that. But let's say the role of service intermediaries, the role of business in, let's say, building up an open data ecosystem is a little bit undervalued, we thought. So since it's typically a field where business is very relevant, we have tried to focus on that specific part of, let's say, the open weather data ecosystem. I promised I would give you some examples related to impact, and oops. This is one of them. It's a story from, let's say, the Western world. It's a story about NOAA, let's say the weather service in the United States. And already quite some time ago, they have decided to open up all their weather data. So not only, let's say, the historical weather archive they have, but also, let's say, the forecast that they provide. And there was really, let's say, the idea over, let's say, the whole playing field there, that opening up data could provide, let's say, a lot more benefits than it would cost to open it up. I mean, of course, opening up data is expensive. Maintaining data and maintaining services is also expensive. But the let's say, the overall view was that, let's say, the benefits of stakeholders using this kind of data would be much higher than the costs. So. Yeah, what you saw was that it really provided, let's say, a lot of opportunities for business, for end users. There's a, let's say, $1 million industry which builds on this data, providing weather services, providing tools and applications derived from the data. And yeah, like I said, the business model that was foreseen was, well, if we open this up, it will cost us a lot of money, but it will bring us much more. If you look at the impact for agriculture in the United States, then you can see that they have estimated that it benefits for about $460 million a year. And there's also examples, and well, the most well-known well-known case is the Climate Corporation, which is also a company which was using weather data from NOAA as its principal data source. And that was eventually sold to Monsanto for quite some money. So let's say that this vision of providing open weather data and building up, let's say, kind of an economy around it, has provided, as let's say, proved to be a good vision in this perspective. And that's only agriculture, of course. I mean, if you look at the whole list of estimated benefits, then you can see that agriculture is only part of it, and there's a lot of other fields and domains that have benefited from, let's say, using this data. So I think this is the best example to see that, yeah, opening up weather data can really help societies and economies. And if you then look at the context, you can see that, well, the policy environment was, let's say, almost perfect. There was a broad recognition of the benefits of open weather data, and there were no major legislative barriers to exploit it. Well, skilled stakeholders, there's quite a big ecosystem of ICT providers which can handle those kinds of data. The technical environment was also quite well developed, and well, economically, there's also, well, because, for instance, there were no acquisition costs for the core data sets for people who wanted to use it. That there was quite some options for very viable business models. There were willing investors, and well, there's high innovation capacity. If you look at let's say some examples from other countries. For example, a service that we're working on in Ethiopia. We are developing with partners a platform, specialized information service for things like crop monitoring and yield forecasting for smallholders, also supporting, let's say, MFIs, microfinance institutes, with information, and providing information to the government for decision making, policy planning, and extension. So there are target users in, well, in the farmers, of course, farmer unions and cooperatives, but also the industry, financial institutions, and the Ethiopian government in this case. There's quite some open data used, but it's mainly open data from, let's say, global sources. So there's a US rainfall archive that is used, and there's European weather data, which is actually a paid service, but very much accessible for, let's say, for use. And let's say the business model there is based on a license model. So farmers, unions, and other users will eventually pay some annual fees to access those services. And if you look at the foreseen impact, and yeah, I should be clear about that, it's still the foreseen impacts still has to be proven by the project. They target at 200,000 plus farmers being benefiting from this work, and intermediaries, higher than 50% of the intermediaries using those services, the improvement of crop productivity, so specifically aiming at improving the yields of potatoes, but also sesame, for instance, as target crops. And then at least also increased number of microfinance and microinsurance customers. So because those institutes can provide better services, they expect also to get more customers for that. Another example is from Bangladesh. It's kind of a similar project, also providing weather-related information to smallholders. Only this time it's, let's say, the main actor delivering the service is a seed company. And they provide advice on uses of the seeds, on how to prepare land, sowing, things like irrigation, fertilizer, etc. So it provides a lot of advice to the customers of this seed company. Again, the target users are farmers, but also agricultural research and university students in this case. And regarding open data, they use the NOAA archives that I just mentioned before. They use historical data and weather forecasts from that archive. Again, there's a business model to, at the end, reach an economically viable service. So there are different ideas for that, fees for phone calls or interactive voice response. There's also subscriptions to be taken on text messages, either text messages or a web application if people are prepared for that. And again, there's foreseen impacts of quite, well, a lot of farmers and the savings they can make in their cultivation practices by using those services. One of the end goals is to develop an economically viable service. So that's all fine, but if you look at, let's say, again, the context of those projects, it's of course a little different than the NOAA case. If you look at the policy environment, and I'm kind of taking those two cases together now, and let's say specifically they will vary, of course, from country to country, but I think this is a little bit of a general picture that we encounter in some of the initiatives that we work on. Well, the policy on open data is in most cases immature or sometimes even non-existing at the moment. There's weather data is often regarded as a very strategic and sensitive data source, and well, that's you can understand that because weather data is also relevant for things like crisis management in let's say, disasters, also for aviation, even national security issues. So in practice, there's quite some, let's say, protectionist behavior also around weather data that we run into. so restrictions in use also. And if you do look at, let's say, the skills of stakeholders, there's still some work to be done, let's say, regarding the awareness of open data, which is still developing. It's in different phases in different countries, of course, but that's one thing. And let's say working with weather data, which is a very technical field of work, is still also a thing where there's some lack of capacity, especially with let's say service intermediaries. Then if you look at open data, we see that open data is used, but it's usually, let's say, globally provided open data from the bigger global weather services. Localized open weather data is generally scarce, for instance, for those, let's say, reasons of protection from, let's say, weather services that are usually under the government, but also because for various reasons the weather data from historical archives, for instance, is not always reliable. Sometimes weather stations don't function for a while, and you have data gaps and things like that. Technical environment is very different over countries, we see, and there's, well, sometimes infrastructure barriers that exclude, let's say, broad deployment of specific services, especially towards end users. But also, if you look at service intermediaries, then you see that sometimes they don't have the access to the tools they would ideally use to, let's say, make added value services. Then regarding the economic environment, there's usually not too much knowledge and experience with using open data business models. There's, let's say, often you see, let's say, the idea that open data is always free data, which is not the case, for instance. Sometimes people don't realize that you can really charge for open data as long as it's reasonable amounts to cover the maintenance and stuff like that. And it's also what we see is that public-private partnerships are sometimes difficult to establish still, especially if you talk about small and medium-sized enterprises. And if you look at service intermediaries, you see that a lot of them are in that category of enterprises. Yeah, very shortly, the conclusions. Well, first of all, we're developing this impact evaluation method, and we are at this point very much emphasizing this whole context issue because we think it's crucial to achieve impact. If you don't know the open data ecosystem, if you don't know the conditions that you're working on, it's really hard to estimate if your project is going to work. Yeah, existing impact evaluation focuses largely on post-project impact evaluations, so it's nice that you can determine if things went well or not and why they went well or not, and it's fine as a learning mechanism. But we feel there's also need for an early stage assessment to be able to, let's say, know and understand what the environment is for open data, what kind of conditions are there. Also to be able to determine opportunities and barriers, and to be able to estimate realistic outcomes and impacts for a project. And I think as important is that it also allows you to be proactive through monitoring and mitigation within and throughout an initiative to be able to make the best of it before the project is ended. So yeah, this is what I wanted to say today about impact evaluation. Like I said, it's work in progress, so I can imagine that we have, let's say, a follow-up presentation maybe in a year or so to present the final outcomes of this specific activity in the GODAN Action project. So I'll be happy to do that in the future. For now, thanks very much for your attention.
Thank you very much, Rob, and it was a very informative presentation, and I'm sure there'll be questions for you, and I will encourage all participants to please send the questions by chat window, and we will have those questions in the end, if that's okay. So we will now move to a presentation by Valeria, who is going to continue on some of the other aspects. So over to you, Valeria.
So thank you, Sashit, for the introduction, and thanks, Rob, for saying so much about GODAN Action. So I will go directly. I will not say what GODAN Action is and what we are doing through the project, but I will focus on what we are doing in another work package, in another focal area of GODAN Action, of the same project, on data standards. I will say something of what we do in general with data standards, and then I will focus a little more on what we did on weather data standards. I will just skip GODAN and GODAN Action because they were already introduced. And as Rob was saying, the GODAN Action project focuses on 3 focal areas. Rob said something more about focal area 2, which is research on demonstrating impact of open data. There is also a focal area on capacity building, but I will say something more about the first focal area, which is data standards. What we do there is we do iterations over these 4 steps for the 3 thematic topics that we have. In the first year, we did this for weather data. As Rob said, this was the first thematic topic for the project. Next year, we will do the same iteration for nutrition data and for land data. The iteration is we first do a survey of existing data standards in this online map of agri-food data standards. Then we do a gap analysis on the use and usability of the data standards that we surveyed. And this we do also thanks to the help of experts that tell us what the actual usability of data standards is in their experience. Then we, based on this gap analysis, we move to recommendations to address the gaps, which is mostly technical recommendation. And then from these recommendations, we build technical specifications, and in the end, we will build services for pilot implementations. So the first step is the survey of data standards. What we do is we built this map of data standards, and the main objective is to provide an overview of what is already existing so that existing data standards can be discovered and reused. Because we believe, and I think it's quite evident for everybody, that being able to discover and reuse vocabularies in data standards makes data more interoperable. The more you use vocabularies and you use the same existing vocabularies, the more interoperable your data becomes. But there's also a second objective. Building this map of the data standards also allows us to identify overlaps, duplication, gaps, which standards are more adopted or less, which ones are endorsed. And it will also perhaps help not to duplicate efforts and collaborate more among actors to develop and use common standards. The approach that we followed in building this map of data standards is that, of course, we didn't want to duplicate efforts, so we tried to build what was already there, and we built on an existing directory of data standards that was called VEST. It was managed by FAO, and we also integrate the data from a portal that's called AgroPortal, which is a portal of RDF vocabularies. So it's technically they're more open vocabularies. We also integrate all the data from there. We wanted it to be a collaborative effort, so we involved experts, and anybody can add new standards there, describe existing standards better. And we envisaged this platform to have a very broad coverage. So it is domain specific because it's for food and agriculture, but we wanted to include all the subdomain that we see as part of food and agriculture. Like we go from agronomy to natural resources, even fisheries, forestry, farm management, everything. All data standards that do something to describe data in these domains are included. And also in terms of types of standards, we have a very broad coverage. It's not just open vocabularies like ontologies or RDF vocabularies, but it's also traditional thesauri in whatever format, taxonomies, code lists, anything that helps to describe and index and annotate data. And we wanted the map to have an open data angle. So we also index all the data standards according to their format, if they are accessible through APIs, if there are mappings between the different standards, the different vocabularies, and the licenses, and all other criteria that help us assess their level of openness. And we also wanted to design this map of data standards for, so that it could be the basis for a gap analysis. And I will say a little more about this later. So it's, as I said, it's a domain-specific directory. There are already a lot of existing catalogs of vocabularies. There is the LOV one, which is a very big one, generic for all disciplines. Now there is also a new one that's called Fair Sharing, which is for all sectors. It's mostly about research and science, but it's really cross-disciplinary. But what we wanted to do, we wanted to do something that was really domain-specific. So the classification of data standards according to domain and according to data type was essential, because people who want to use data standards, they have to be able to search the right data standards for a specific type of data. So there was nothing existing, so we couldn't find an existing domain classification that was agreed upon by everybody. But we looked at classifications from big organizations like FAO or USDA, and we found that they were very similar. So in the end, even if there wasn't a standard classification, big institutions were using very similar classification to classify the subdomains of agriculture. And we ended up with this classification on the right of subdomains. But for data type, that was going to be much more granular and more specific, because it's not enough to understand, to choose the right data standard just looking at the subdomain that you're working in, but the type of data that you have to manage is essential. So we went for a much more granular classification of data types, and we didn't want to start from scratch. So we aligned this with the work that was being done in GODAN on the agricultural sector package for the Open Data Charter. They were already working on a classification of different data types, so we joined efforts, and we tried to have we have a very long classification of data types. What you can see here in these two boxes on the left are only examples. These are subdomains. For instance, on the right, these are subdomains of natural resources. We have land use data, but also it's not here, but we also have land cover, and we have several other subdomains for land, and we have soil data. We have also subdomains for weather and climate data. This is what the map looks like at the moment. You can go to the homepage of the website at westagrisemantics.org, and these are just two charts that demonstrate the distribution of data standards across domains and across types of vocabularies. I will not go into details into that. You can go to the map and you can see what the breakdown is. But what was important for us, the map had to be useful also to assess the data standards, to understand what the situation was in terms of usability of standards, adoption, if there were gaps, if there were overlaps, etc. So we also used some assessment criteria, and we didn't want to start from scratch, and we started from two existing sets of criteria. One is from the UK government's Open Standards Board, and the other one is the BI Open Data Certificates criteria. The first one is more really on data standards, and the second one it's more for data sets, but since many data standards and vocabularies are nowadays published as data sets, many of the criteria there were suitable also for this assessment. And we grouped this criteria under 4 categories of assessment. One is the fitness for purpose, the level of adoption, the usability, and the openness of the data standards. And you can see some examples of the criteria that we used. These are all metadata that we have in the map of standards. So whenever we catalog a new data standard, we answer also all these questions on, for instance, the level of adoption of the data standard. And what is relevant in terms of adoption is if the data standard is used in software, if it's used in data sets, if it's actually endorsed by many organizations, if it's in some way regulatory, like an ISO standard or a government or regional regulation, if it's long-term, if it's sustainable. These are some examples of the criteria for the usability, for the level of usability of a standard, if it's available in different formats, so it's easy to use, if there are APIs or web services that facilitate the use of the standard, and if it's managed in some online collaborative environment. For the openness, these are mostly criteria that come from the ODI, the Open Data Institute criteria for assessing vocabularies. It's, of course, if it is available in machine-readable format, so it's much easier to use and it's open. If it is meaningful, meaning that it uses RDF vocabularies, this is a technical thing, but it's very useful for developers to have data standards and vocabularies in this format. If they use URIs for terms, or if they're linked to other vocabularies, which means that you can use several types of authorities to index the same data. And this was in general about the map of data standards. What did we do with weather data standards? The weather data, the topic for the first year is actually more narrowly specified into a use case, that is the use case of weather data used in farm management information systems. So what we did in the first stage was the survey of existing standards, and we surveyed both weather data standards and data standards used in farm management information systems. And we came up with a total of 65 weather data standards and farm management information data standards. We also had to make the classification of data types a little more granular and add new subtypes, let's say, of data. We had a generic category for weather and meteorological data, but after going into the survey, then we specified better that you could have different type of data sets for which you needed data standards, so weather observations, but you can also have weather monitoring infrastructure like sensors, climate data, which is of course different, which requires different variables, and weather forecasts. And we also had we had to refine the classification of data types under farm management data. These are some examples of the data standards that we surveyed and that are now in the map of data standards. Those of you who work with weather data will probably recognize most of them. Some of these are from the WMO, so they're part of the broad infrastructure of the WMO. Some others are more are developed by the Open Geospatial Consortium, and we also have some standards like the ICASA variable lists, which were developed for farm management, and they also include weather variables. So in the end we ended up with more or less 65 data standards. It's not a complete survey, of course there will be more, but we involved a lot of experts in this work, because of course we needed to be sure that we were really representing the most important data standards, and we were also able to assess them in terms of authoritativeness, adoption, etc. So these are the experts that we consulted, and that helped us a lot in this work, especially in the gap analysis. Based on the content of the data, the vocabulary map, we ran a first gap analysis, and we tried to summarize the results of this, because 65 data standards were of very different types. And this is a very short summary of the results. The document is very long, it's like 50 pages long, but quickly summarizing the results, of course what was evident was the variety of data formats, vocabularies, and data models that are used in this domain. The fact that there are standards that have been there for decades and are still authoritative, because they are, of course they were developed by the WMO and they're used everywhere in the world, and they're also used for legacy reasons, because they've been used for decades, and there are a lot of tools that depend on these formats. The same for the NetCDF format. It's used by researchers. There are a lot of tools that can use it, so it's still used a lot. Then there are newer standards established by the Open Geospatial Consortium and the ISO community. They're especially geospatial standards. They're not really specialized for weather data, but they're now starting to use this as a basis for standards for weather data, because they're for observations, so they're of course valid for weather data. And then there is a different type of standard that is used by end user services, like APIs, web services that provide very dynamic data sets that you can query, and you can get JSON files, CSV files, and these are used mostly by developers to build added value services. A general observation about the work that is being done both for weather data standards and for farm management is the work on variable naming conventions. There is no global standard no agreed standard on variable names, but there has been work, for instance, in the weather data community on establishing some conventions. For instance, for the NetCDF, there are the climate and forecast conventions for variable names. For farm management systems, the ICASA consortium has built a list of authoritative variable names. So the summary of the gap analysis of the main problems, of the main challenges, let's say, in the usability of data standards, first of all is the a general issue of discoverability of weather data. This is not really related to standards, but we will see later that we tried to also, let's say, analyze this problem in terms of what data standards can do to improve the situation. Another issue is that what experts said is the data standards are usually not very well documented. It's not clear which standards one should use in certain contexts for weather data, or which standards one should expect to find to describe weather data. And again, the problem, as I said, of variable names, which are different, and there is no mapping between different code lists that are quite authoritative, but they're used in different environments. And there is still very little use of linked data in vocabularies for weather data. Based on this short gap analysis, this is a summary of the gap analysis, we came up with a very short list of recommendations for improving the use and usability of weather data standards. So to address the discovery issues, the solution in terms of data standards would be perhaps to use more and better discovery metadata for the data sets, like using vocabularies that are dedicated to the description of data sets and the discovery of data sets, like DCAT, but also other dedicated standards for statistical and observation data sets. And improve the documentation and self-description of data standards, because many experts were complaining that they're not documented, really not easy to use, and offer perhaps community support and questions and answer services. And the third one is identify some of the key code lists that are used by many of the researchers and the people who work with weather data. There are authoritative code lists, for instance, from WMO, but also the variable lists, etc., that could be published as RDF in linkable formats that can be easily reused. Some of them have already been published like this, but not by authoritative bodies and not in a linked way. So there is no crosswalk. There are no crosswalks between them. So publishing them, aligning them, and perhaps providing crosswalks between these code lists would be one of the services that our experts said could help. The next steps, what we're going to do now, we are based also on these recommendations and especially offering community support. We're going to build a data publication online help desk to help to let's say, experts, data standards experts and data owners meet, and so that experts can provide advice on how to use data standards. And then we will do through the same iteration, as I said, for nutrition data and land data. And we will move to technical specifications for improving the interoperability of data thanks to standards. And we will develop services for pilot interventions. And this is where perhaps our work will meet with the work that Rob's team is doing, because the pilots will have to have an impact, and we will have to choose pilots that will demonstrate the impact of better data standards on the actual usability of data. Thank you.
Thank you, Valeria and Rob, for your informative presentations. And now it's time for questions. We are having some questions in the chat window. So I will start with the first question. One of the participants, Peter Balaba, is asking, he has been using a data from YR.no. Sometimes it's not realist. So he's asking for, if you are aware of any accurate weather forecast data, any other sources for weather forecast?
Yeah, I know a few of them. I already mentioned, let's say, the NOAA and ECMWF data sets. They have forecasts, and they are quite coarse, so that's not, let's say, usable for every situation. It's usually a good base, but you usually want to have also local weather information. And that's exactly where the problem is, I think. I know there's something like Open Weather Map, which is a site that provides data from different sources, also from NOAA, through APIs. But they also provide, let's say, crowdsourced weather data from, let's say, private weather stations. And I actually haven't used it myself, so I cannot really judge about the quality of it, but at least they provide, let's say, a lot of local data from weather stations. So you could take a look at if that works for you. And other than that, it's very dependent on the country and the region that you're in and how people are dealing with weather data in that specific region.
Yeah, that's very useful. In fact, we will have all these slides recorded and sent after the webinar. So, for example, the NOAA site and all those things. If Rob, if you can send the URLs through the mailing list as well, I think it might be more useful for the colleagues to know more information as well. So I will request you to do that if possible. Just 3-4 URLs of some of the links you mentioned specifically. That will be very helpful. Thank you, Rob. Okay. So we have another question coming from Jarmo Sariko. And Jarmo is asking, who should or could establish a code server where different kinds of code sets could be stored and published? Then establishing linkages between these might be easier. So he specifically says that code server is different from a thesaurus, where, for example, FAO is using for sharing ontologies and thesauri. So this is again a technical question. So Rob, any ideas?
Well, I would say Valeria might be the best person to answer this question.
Okay, it depends if it is if what is envisaged is a central, let's say, directory of all weather data sets. I don't think that's going to happen. What we've noticed in our survey, although the survey was devoted to standards, but in the end we also surveyed some existing servers that were providing data. What's happening is the data that are served depend a lot on the audience that is using the service. So there is no universal data server that can serve the data that everybody needs, because there are different audiences that need different types of weather data. So normally services are very customized to their audience. What we wanted to do was to try and provide a one-shop place, let's say, where you can find all the data standards and perhaps also the machine-readable version of the data standards to facilitate access to the data. But a central server of all weather data is not something that I foresee. That I don't see any organization that would like to do that. Unfortunately, I understand that there might be a need, but it would be really impossible to serve all the needs of all possible audiences.
Well, maybe to add to that, what I just mentioned, Open Weather Map. I think actually what they're doing is a little bit like that, like providing data from different sources in kind of a uniform format. I'm not sure about their policy for the future, but I know currently they kind of stream data from different sources in the same format, in the same API format to end users. But you have to realize that that's a paid service. Yeah. It has advantages, but it's well, paid service.
Yeah.
Right. Thanks, Rob and Valeria. Another question that is from Yanina Sabini is on which standard is used to share radar meteorological data and which to share rain calculator from radar metadata?
I guess that would be for me, but I would need to look at the map, because it's we have as I said, we classified the data standards according to the type of data that they describe, not necessarily the type of source of data. Like, for instance, if it's radar data, if it's data coming from sensors, etc. But there are also data standards that describe the infrastructure, like sensors, radar, etc. If you go to the map of standards, the vestagrisemantics.org, you can search by whether, let's say, infrastructure and whether type of data, and you can find something. As I said, it's not the map as it is now, it's not really comprehensive. We cannot say that everything is there. So you may find very little for that. And it could also be that there is no specific data standard for that. Maybe there is just a generic data standard for like rainfall, and not necessarily so specific.
Right. Yeah. And Thanks, Valeria. I think the information again. You'll be sending this. We'll be sending the slides. So hopefully, colleagues can get more information. And especially, I like that slides on that map showing the geospatial, the standards mapping exercise you did, and that will be really useful for the geospatial community as well. I don't know how many of them are here today, but I will make sure the recording is passed on to the geospatial communities, because I'm sure that they will come with a lot of your feedbacks and ideas directly to you later. So we will follow up some of these ideas later as well. And one question from there's actually a clarification from Jarmo regarding the previous question. He's asking not data but the metadata for the coding, the value set and labels for different variables.
Yes. Yeah, okay. In that case, I understand the question better. Yes, and this is one of the things that we are proposing as recommendations to facilitate the use of standards, to have lists of variables and code lists that are used published somewhere as linked open data and linked among themselves, because many of these code lists express the same types of variables in different ways. So if you publish all these lists and you link them, and then you provide some web services for crosswalks across all the different ones, you can easily convert from one format to another. Like if you have a data set that uses GFAR codes, which are the WMO codes, and another one that uses the NetCDF convention variables, you can easily do the mapping, and then you can go from one to the other and convert very easily. So after talking to experts, we found that one of the things that they would find very useful is this, having a server of all the possible variables and code lists with URIs, univocal definitions, and mappings. So I hope that there is nothing like that now, although there is a service. I think it's provided by the NERC, NERC. One of the links is in the presentation, I think, but I can send it separately. And what they provide is they tried to publish the most important code lists as RDF and provide also some mappings. So that's an initial exercise that's very useful. It's not universal, it doesn't include everything, but they saw this need and they tried to provide an initial service that's very useful. So I will send you the link to this service where already a lot of code lists are published. I will send you that.
Thank you, Valeria. Thank you, Valeria. And one more question from Paul, who again thanks you for all this useful information. And he would like to know if the help desk can be accessed worldwide.
It will be. We're still deciding. We're still deciding if we want to build a new platform for that, or if we want to reuse something that's already existing, some questions and answers service that's already established, so that people are already subscribed there and we can build a community there, or if we want to build something new. Actually, feedback from the community would be useful to understand if they would prefer to have something that's dedicated to data standards for food and agriculture, or if they would prefer to be involved in a broader community on an existing questions and answers service. But it will be open anyway, of course, to everybody.
Thank you, Valeria, and thank you, Rob. Rob, one more question. Because this is the last question, but I want to provide this question. This was the issue of lack of ICT knowledge by service provider stakeholders that was raised by Rob. What will be the right remedy for the challenge? Yeah, because in your presentation, you mentioned about the lack of the issue on the lack of ICT knowledge by service providers and stakeholders. The question that Peter is asking is, do you have any right remedy for this challenge? Anything you think, might be a solution, optimal solution for, especially, because the case studies you are mentioning were on developing countries, Ethiopia, Bangladesh, and other developing world. They will all face the issue of ICT knowledge, and so from your experience, what do you think might be kind of a solution or possible kind of solutions for this?
Well, I don't have the full solution, I think. I mean, I think part of it is probably a natural movement. I mean, things are changing very fast, of course. If you look at ICT, both from the infrastructure side and from the, let's say, knowledge side. What we will specifically do is, let's say, explain how you can use open data and what the advantages are and how you can use it, and also, like Valeria also explained, explain a little bit about weather data, how it works, what the standards are, and how you can use them. And that's, let's say, our probably small contribution in this big issue. So that's what we can offer. And let's say apart from that, I mean, there's a lot of things happening. So I'm not that pessimistic about it. And yeah, like I said, I mean, working with weather data, for instance, and the technical issues that you run into over there, we can help with that. Other than that, it's also, let's say, a much bigger issue, and there's a lot of things happening. And like I said, I'm optimistic about that, and things are going really fast.
Yeah, thank you, Rob and Valeria, for your informative presentations and active discussions on this. We are now approaching time for the end of the webinar, so I will conclude the webinar here. But we welcome questions and more interactions via our mail list. So I will welcome all participants to join our mailing list, and if you have any more questions, do because of time constraints, we are closing it now here. But we will be more than happy to continue this discussion in the mailing list, and you are more than welcome to contact both Rob and Valeria directly for any of specific information you need. So again, I want to thank all participants for joining us today for our GODAN webinar, and all the speakers and CTA for hosting this webinar. And we will be having the next webinar sometime next month, and I will inform this through the mailing list as well. So thanks again, everyone, and we will see you all soon later. Bye for now.